Hello everyone, my name is Valerie Gonzalez and today I'll be presenting on the topic hydrochemistry and water quality in the East African Rift Valley. The East African Rift Valley, or the EARV, is a fascinating and geologically active region, but its unique geology presents significant challenges for groundwater quality, public health, and the environment. Let's dive in. The EARV is defined by volcanic activity, faulting, and fractured zones, all of which shape groundwater quality and availability. My research explores three main questions. One, how does the geology of the EARV influence groundwater quality? Two, what public health challenges arise from fluoride contamination? And three, how do climate change and land use affect water availability? To answer these questions, I highlight the need for better groundwater management, public health initiatives, and sustainable practices to combat water scarcity and contamination. We start off by locating groundwater sources. So, in countries like Mozambique and Uganda, volcanic rocks and fractured zones create critical groundwater reservoirs. In Mozambique, fractured basement aquifers with resistivity ranges from 100 to 500 ohm meters provide essential water resources in rural areas, though they remain underutilized due to infrastructure challenges. Similarly, in Uganda, weathered zones with resistivity values below 260 ohm meters hold significant potential but require more exploration and development. These examples show how geophysical methods like resistivity surveys are essential for identifying and utilizing these water sources effectively. One major issue in the EARV is fluoride contamination, which occurs when groundwater interacts with volcanic rocks over long periods of time. In Tanzania, fluoride levels range from 15 to 63 milligrams per liter. This far exceeds the WHO limit or the World Health Organization limit of 1.5 milligrams per liter. In Ethiopia, fluoride levels reach up to 9.8 milligrams per liter. This severe contamination causes health problems, especially in communities that rely on volcanic aquifers without access to alternative water sources. Fluorosis is one of the most serious consequences of high fluoride levels. It leads to dental and skeletal deformities, especially in children, causing chronic pain and long term disabilities. The most affected areas are near volcanic formations in Tanzania and Ethiopia, where access to safe drinking water is extremely limited. Addressing this issue requires public health initiatives and alternative water sources to protect vulnerable communities. Climate change and land use practices exacerbate water scarcity in the region. In Ethiopia's Mekki Basin, groundwater recharge rates have dropped by nearly 50% due to rising temperatures and agricultural expansion. Seasonal changes also affect water availability, with most recharge happening during the rainy season. Land use changes like deforestation for agriculture further reduce groundwater recharge by increasing surface runoff. These pressures highlight the urgent need for sustainable water management strategies. Rwanda provides another example of how geology and limited exploration impact water access. Volcanic rocks dominate the northern regions near the Virunga volcanic area, but the lack of geophysical surveys forces communities to rely on shallow aquifers that are unreliable and often dry up. Other countries like Djibouti, Malawi, Burundi, and Eritrea face similar issues due to limited data, inadequate infrastructure, and poor groundwater development. In conclusion, the geology of the East African Rift Valley significantly influences groundwater quality and availability, with volcanic rocks and fractured zones providing essential reservoirs, but also causing challenges like fluoride contamination. Climate change and land practices further strain water resources, reducing recharge rates and increasing vulnerabilities. Countries like Mozambique and Uganda highlight the potential of fractured aquifers, while regions like Rwanda show the need for more geophysical surveys. Addressing these challenges requires improved mapping, sustainable water use, and public health interventions to mitigate health risks and ensure safe water access for communities across the region. Thank you for listening.